Hi, welcome to 5.6, Deductive Proofs. Okay, so deductive reasoning can be split into two major sections: proof by direct argument and proof by contradiction. Okay, there are direct argument proofs that we're going to talk about four main ones. There are many kinds of deductive proofs. Okay, so I don't want you to think this is not an exhaustive list. Okay, there are so many, but those are college level. So we're going to just talk about four just in this course. Okay, you have law of deduction, which you might want to put a little star by that. That's going to be the one we use the most in this class. And then there's modus ponens, modus tollens, and transitivity. Okay, those number 2 and number 3, those are Latin words. Okay, modus means manner or mode. Ponens means placing or asserting. Okay, and then tollens means bearing, taking away, removing, or denying. So if you're in Spanish, you might have heard of the verb to put is poner. Okay, so that's how I remember. Modus ponens means I'm going to put. Okay, the way I'm going to put. So anyway, we're going to get into this a little deeper with the individual arguments, but I just want to see if you can know some Latin already, like maybe on your coins. Okay, e pluribus unum. If you don't know that's on coins, it's also in The Wizard of Oz, if you ever seen that movie. It means one from many. Okay, that's probably the most common Latin thing. There's also something where, I know I showed you the therefore symbol the other day with the 3 dots. Okay, another way people mark the end of proofs is QED, and that is Latin that you put at the end of a proof that means that which was to be demonstrated, and it's like quod erat demonstratum, something like that. I obviously am not very good at languages, but anyway, QED you'll see at the end of proofs, probably in Algebra 2, and just so now you'll know what they mean. It just means the end, kind of. Okay, so the law of deduction is a method of deductive proof with the following symbolic form. Really important that you memorize these. Okay, this will be on your quiz, it'll be on your test, so we need to talk about what premise and conclusion, it follows a certain format. So, law of deduction starts with P, which is assumed. Okay, so that would be like your given, and that's how we're going to be doing proofs. We're going to be have a statement that is given, and we have to assume it to be true. Okay, then you're going to have statements that we know are to be true, as many as we need. So we have statement 1, statement 2, statement N, okay, as many as you need, so that you can come to a conclusion, which is your R, and that's deduced from all the statements that you've made. So no matter how many you needed, whether it's 1, 2, 3, or 100, you actually have a conclusion, and then you can say P, if P, then R, and that's your conclusion. Okay, so modus ponens is a method of deductive proof with this symbolic form. If P, then Q is what you're starting with. So the next premise is that you have P, and then your conclusion is therefore Q. Okay, and then you have your modus tollens. Okay, so you will have your the bearing, remember, taking away, removing. So you'll have your P, if P, then Q, but then you're talking about not Q, therefore not P. Because remember, not P, if not P, then not Q is also true, because remember that's the converse. And then transitivity. Transitivity is much like substitution. We've talked about this a little bit when we were talking about our different rules, right? Our rules of equality and equivalency. Well, this is doing it with statements, with words. So if P then Q, if Q then R, so then you can just do kind of a switcheroony where if P then R, you're just taking out Q as the middleman. Alright, so this slideshow skips example 1. If you want to look at it, it's on page 190, and it's a proof. It's a straight up proof. You have a given, and it talks about all the different pieces that you have to end with your conclusion. Okay, it's a really good thing to just look over because we've already done this proof. This is the proof of midpoint, and we've already done it in a previous lesson, so I didn't put it in here to review it. Alright, when we looked at the very first proof, this is it as using law of deduction. So we're skipping to example 2. So if we need to classify this argument, we have the first premises is if a man is sinful, then he must die. Premise 2 is man is sinful, so now we can draw a conclusion. Man must die. Okay, so this argument has the form, if you look at it, of modus ponens, okay, and it is valid also because it's based on true biblical premises. So that means it's true, it's valid, that means it's also sound. Okay, so I hope you're hanging with me. Remember, you can always rewind these videos. Please remember that. I talk pretty fast just because I want to keep the length of our videos as short as possible, but by all means, rewind and listen again if you missed something. Okay, so let's do another one. This time I want you to read it, and then I want you to guess. This is a multiple choice. Is it 1, 2, 3, or 4? I want you to go ahead and you do your most educated guess and see if you're right. So, if it rains today, the ball game will be canceled. It rained, therefore, there's my 3 little dots in the shape of a triangle, right? Therefore, the ball game was canceled. Modus ponens again. Okay, so if you can see that, I've got my if P then Q, P, therefore Q. If we eat carrots, then our eyesight will be good. Our eyesight is not good. Therefore we don't eat our carrots. So, think of it as if P then Q scenario. What do I have? Yeah, I'm talking about if P then Q, not Q. Okay, so the Q part is second, right? Our eyesight will be good. Oh, my eyesight's not good. Not Q. Therefore, not P. Okay, this one's a little trickier because we don't have actual words. So, we're starting with R. R, therefore, P. Now, see if you can remember what the upside down V, or the upside down carrot is what I call it. The V looking thing is. Okay, if you can remember, it means, it's like union, and union is and. Okay? Then not P or not Q, therefore not R. Okay, it's a little bit more complicated. See if you can piece it together with as though there are P's and Q's only. Okay, if you got modus tollens, you're good because, okay, look at it carefully. If you say R is P, alright, and then it is Q, which you can replace the Q with the P or Q, right? That, you would have to negate all of that. So if I say not P and not Q, that is the converse of P and Q. Alright, that is the negation. That's the complete opposite. And therefore not R. Okay, so hopefully we can work through that one. It's hard to say it verbally. It's much easier to show you, so if that needs to be your question, by all means. Okay, so angle A is congruent to angle B. Angle B is congruent to angle C. Angle C is a right triangle. I'm sorry, right angle. Therefore, angle A is a right angle. Right? There's some substitution going on there. So this one I feel like is the easiest one to recognize. Okay, the other three, you just get used to recognizing them as you practice. Okay, so remember how I told you in section 5.5 there were more fallacies? Okay, so we need to talk about a couple more. So there's two more fallacies that arise from misuse of modus ponens and modus tollens. These fallacies are assuming the converse and assuming the inverse. Okay, you can't always do that. So let's do an example. Classify the fallacy committed by this argument. Okay, so we're going to use the three fallacies that we already know. All dogs are mammals. Fido is a mammal, therefore Fido is a dog. Okay, what kind of fallacy is this? Because we already know Fido could be a cat. Okay, so I think right here you can assume that we are assuming the converse. Okay, so just to be clear, we have three fallacies we learned previously. Now we're adding assuming the converse and assuming the inverse. So now we know 5 fallacies. Okay, so we assumed the converse. All U.S. presidents are U.S. citizens. Ken is a U.S. citizen. Ken is a U.S. president. Which one did we do? Which fallacy did we do here? Yeah, this one's also the converse. Okay. Practice again here. All whole numbers are integers. -5 is not a whole number. -5 is not an integer. Okay, hopefully you recognize that as an inverse. If this might take some vocab to go back and review. Maybe you don't remember what converse and inverse mean. Okay, if you don't, you need to go back to Quizlet and review those terms. Okay, so for your WISC summary, this is a little bit tricky. Okay, I'm trying to lead you a little bit here, but I know you can do this. Okay, if you take your time and really do some thinking, I know that you can accomplish this summary today. In 1 Corinthians 15, verses 13 through 20, Paul uses a deductive argument. Which kind does he use? Does he use more than one? And I want you to write the premises and the conclusion Paul uses. So I want you to do your best with coming up with if P, then Q. I want you to know what P is and what Q is. You're going to have to break this down a little bit with verses. Give me the reference on how you're coming up with that. Okay, and remember, not P and not Q are the opposite, the consequences, right? He talks about resurrection and consequences. And so, anyway, do your very best. I actually have maybe 6 or 7 sentences to describe everything, so I expect it to be about that length. If you can't get it that long, just submit it. Remember, this isn't about right or wrong. This is about participation. So do your best, and I will see you in class.